Hi students. So today we're going to be connecting how an area model can connect with an algorithm when we're multiplying a 2-digit by 2-digit number. So first we're going to start with our area model, and we're going to break our 35 into tens and ones. So we're going to have 5 in our ones and 30 in our tens. Then we're going to break our 42 into tens and ones and have 2 in our ones, and 4 or 4 tens would be 40 in our tens. Now we're going to multiply them together into each box. So I'm going to multiply my ones. Well, let's start with our ones and ones. Ones and our ones multiplied together is going to make 10. And our ones and our tens multiplied together is going to make 60. All right, now let's do our ones and our tens. 5 times 4 is 20, and I'm going to add that 0 on to make 200. And then we're going to do our tens and our tens together. 30 times 40, which would be 12 with 2 zeros, one for that 0, one for that 0. Okay, now I'm going to actually add together these two products to have 60 plus 10, and that's going to make 70. So both of these products together is going to make 70. And then if I add both of these products together, let's see what that's going to be. That's going to make 1,400. All right, if I add both of these products together, it's going to give me my final answer. So if I add 70 and 1,400, I'm going to have a final answer of 1,470. Okay, now let's come over here and let's say, okay, I am so good at area model and figuring this out. How does that really relate to the algorithm now? Well, if you look at the algorithm, we have a pattern that goes on. We have this pattern that you times the ones and the ones together, and then the ones and the tens together. You may have seen this pattern. And then we come over and we do the tens and the ones together, and then the tens and the tens together. Well, that's really happening over here in our area model. If you see, we just did tens and tens together, or ones and ones together, and we got 10. Look at over here. 2 times 5 is 10. 2 times 5 is 10. So we have to carry our 10 over into the tens and put our 0 here in the ones. Now we're going to come over and we're going to multiply this 1 with this 10. 2 times 3 is 6, plus that extra 10 that we just carried over is going to be 7. Notice that we just got the same answer. We multiplied ones and ones together and ones and tens together, just like we did over here. Ones and ones, ones and tens. We got this partial product of 70. Let's see if it works with this bottom number. Over here we did ones and tens and tens and tens. So over here we're looking at it. Because we're working with tens now, we have to put a 0 right here, because if you think about it, this 4 is really not 4, it's really a 40. So if you think of the number 40, you've got to have that 0 in the ones place to hold that spot and really make it a 40 instead of just a 4. So that's what the 0 is doing. So always add a 0 right there. And now we don't have to worry about forgetting to put a 0 and say 4 times 5 is 20. And we have to carry a 2 up here now and put our 0 down here. Now, a trick that I always, or a mistake that I always see students do is they'll put a 2 right here and say 20. But you can't put a 2 right here because you haven't times your tens and your tens together yet. So if you times your tens and together, then you, or tens and tens together, where are you going to put your answer? So this 2 really does have to be carried up here until you're finished multiplying all of your place values. All right, so now we can do, we just did our tens and our ones, just like we did over here, tens and ones. but now we're going to do tens and tens together. That's like we are doing 30 and 40 here. So 4 times 3 is 12, plus 2 more, 12, 13, 14. And we really get that 1,400 if you added the 1,200 and the 200 together here. You're getting 1,400 for that partial product. So you can really see right here, there's where you're timesing your ones and your tens, and this right here is where you're timesing your tens and your ones and your tens and your tens. So now we're going to add those both together, and here we have, ta-da, the same answer. Okay, so you can see how the algorithm is just a faster way of putting your partial products together, but you do have to be good at a pattern. You have to be good at going tens and ones, or ones and ones, and ones and tens. Then moving over, putting your 0 in, and doing tens and ones, and tens and tens. That is the pattern that we're working for. Okay, we're gonna do this one more time, kind of a little more in fast motion. We're gonna start with the new problem. Okay, first with our algorithm, we're breaking this apart into 60 and 2 and 7 and 30. What is 6 times 7? 6 times 7 is 42. Add that 0 on. 7 times 2 is 14. If I added those together and said 420 plus 14, I would get 432 as my partial product. Now I'm going to do my tens and my ones, which is going to be 60, and my tens and my tens. 3 times 6 is 18. Add 2 zeros because I'm timesing by 2 zeros. And I'm going to add 1,800 plus 60 is going to be 1,860. Let's see if we get the same products over here now. Here's our pattern. Ones and ones, just like we did ones and ones. That's going to be 7 times 2 is 14. Carrying that 1 up here. Now we're going to do 6 times 7 is 42. Add in the 1 more. Don't forget to add that in. So 6 times 7 is 42, plus 1 more is 43. Did I get the same answer? Ooh, so far so good. Okay, now that we're moving into tens, what do? We have to hold that 0 because now we're not working in the ones anymore, we're working in tens. That's really a 30. We're saying 30 times 2, really. 3 times 2, because I dropped that 0 off, I don't have to think about that 0 for a minute. 3 times 2 is 6, which 30 times 2 really is 60. And now we're going to, so that was our pattern of tens times ones, just like over here. 10 times 1 was 60, or the tens times the ones was 60. Now we're going to go and do this 10 times 10 one. What's 3 times 6? 3 times 6, so 6, 12, 18, right? 3 times 6 is 18. I don't have to do any carrying. I'm going to drop it right into my answer. Okay, look at my partial product here. Da, da, da. Same. Add those up. 6, 7, 8, 9, 8, 9, 10, 11, 12, and 2 more is 2,292. Oh, okay, over here. I didn't add these partial products up. I'm like, wait, where's our score? Okay, 1,860 plus 434, 6, 7, 8, 9, 8, 9, 10, 11, 12, and ta-da, we have same answers. Okay, so I hope you can see now that the algorithm is just another way of making these partial products happen. It's just going to be more time efficient. So that's what we like to do with math, is we like to do math the most efficient way. So practice, practice.